So at this point, we've got a couple of things on our mystery list that we'd like to figure out why they're occurring. First, why GCC is overallocating space when it's only saving a frame pointer, for instance, in the case of our just returning function. And then for our single local variable, why does it overallocate space for that as well? So to figure this out, I'm going to invite you to play something I like to call the inference game. So the objective is to figure out the answer to those questions. Our approach in the inference game is to feed multiple program inputs to the compiler, observe the stack usage, and infer why it's doing whatever it's doing. So we had a single local variable with a single int I of scalable. Now let's go to TwoInts.c, two local 32-bit variables, scalable and obsolete. Compile it, get this code, and no new assembly instructions, so that's good. You can just go ahead and look at this and figure out what's going on. So the stack at the start of that code looks something like this. Your frame pointer is going to be pointing here. Your stack pointer is going to be pointing there. Again, we don't care what's already on the stack. We just care what does 2ints optimization level 0 place onto the stack. So all right, stop and step through the assembly, draw yourself a stack diagram, and start to infer the differences between your previous diagram for a single local variable and your new diagram for 2ints.